Boom. Cool. So I asked a couple of people to do some prep work, um, Alex and Jack. But the idea of this talk is to have a few different folks walk everybody through their forecasting process, because I'm sure it's going to be a little different. And then there's going to be some things that are common to everybody and some things that are a little different, and talk through the rationales of what's going on and why they do what they do and what tools they use and kind of what tools are good for what. And I'm sure it's going to depend on kind of what kind of flying you're into. And then, so I asked Alex to kind of prep a little bit and Jack to prep a little bit. And then I've got a little stuff to share. And then we can open it up. And if other people have stuff they want to chip in and share or questions or whatever, we just like want to slag each other and call bullshit on one another. It's going to be awesome too. So cool. Shall we begin? All right, I'm going to mute out. We're going to go to Alex, Papa Alex, who I learned a shit ton of my forecasting from. So I asked him to kind of kick us off with a big picture stuff and then go through his process. All right, I'll shut up now. Go, man.
Yeah, so Patrick asked me to lead off. He didn't say prep. I didn't do a lot of actual prepping, but it's not hard to describe what I do as far as weather. And I've been doing the same thing for a long time, kind of stuck in a rut, but it's awesome to have new guys joining the group who have completely expanded not just but all of our horizons in terms of what we can predict or look at and what we're actually looking to find out about. What kind of flying we want to do, like Patrick said, makes a big difference. So yeah, anyway, my focus is always generally been on, is the weather going to be nice enough for me to fly tomorrow, or even like waking up in the morning? Is it nice to fly today? I don't really worry about a long-term forecast trend, even though we can look that far ahead, but I don't typically. So because I'm flexible enough in my work and family situation, I've pretty much designed my lifestyle over the last few decades around flying today. So for me, I want to know, where am I going to go today? And it's nice if I can peak a few days ahead. I don't really care much farther than that, but to make a plan for, people want to do stuff, the family wants to do stuff on a certain day. I got to see, that's the day that I'm hoping that we can fly the knob or something. So I'll try to look ahead and figure that out. But the main thing I'm looking at is, for me, is it fair weather, not raining, and what are the surface winds going to do? And that pretty much tells me where I'm going to start looking at my flying. Obviously, if we have strong surface winds, that's going to be more likely that we're going to want to be on the positive side. If it's light surface winds, maybe we can fly somewhere that's a little more protected. But yeah, so I'm looking at surface winds, and my process of surface winds used to be a tool. I used to use a tool we had called the Blip Map, which was programmed by a sailplane pilot on the Big Island, which was awesome. And in recent years, that thing went defunct, knocked out by a hurricane, and we ended up finally replacing our old Blip Map with a new system that is pretty similar programming is called a RASP, and it is still a Blip Map, but I don't love the new wind model on the RASP that we have programmed for us, so I don't rely on that one as much. I do look at it, but I don't feel like it quite gets what is going to happen as accurately as our wind alert WRF model. So if you don't have access to that, you should get access to it. I feel like for surface wind prediction, which is my main focus, that there's no better model than that. And it's short term because it takes a lot of computing power to compute just a few hours of it. So the most you're ever going to get on the WRF is like a day or two ahead. But if you want a longer view than that, I would look at maybe the Euro model on windy. I feel that's pretty accurate for what's coming. Yeah, but other than that, I mean, so I'll look at the forecast discussion to get a idea of the big picture of pressure systems and overall weather pattern. Do they expect a lot of rain or not, and why? And then I'll look at the 7-day forecast for the zones, where they'll break it down by each zone and say, for the windward side, or for Ko'olau, we're looking at 10 to 15 northeast, 20% chance precipitation. For me, that's like the perfect call for Kahana. Or I'll look at like light northeast, maybe and low precipitation, maybe start at Makapu. Or if it's like light southeast, maybe good west side day, or light north, maybe that's a good knob day. But so I look at that stuff, and between the WRF and the 7 day zone and the forecast discussion, that's mainly what I look at. But I also bring in a few other things. I look at the TPW, total precipitable water, to get an idea of moisture trends. If there's any question about, let's say we want to shoot for a sunrise flight, I want to know, is it going to be reasonably dry morning? Out here, that's kind of rare. We're like the wettest part of the island right here. If there's any chance of moisture, it's going to be here. So if I can see the TPW shows, it's a 24-hour loop of the prior 24 hours. If it shows a nice dry parcel marching towards us, and it looks like it'll probably be in the area vicinity around morning time, then we have a better chance for sunrise than an average day. So that kind of stuff is what I look at. I don't
Where
know
are
if I
you
left anything.
finding, uh,
I don't know if I left anything out of there, but
what are you looking at for the TPW, or where are you finding that?
yeah, I don't know. It's I can send a link to the group for that. It's let's see, where is that? Hang on. Can I share my screen? How do I share my screen? I never did it. There's got to be a way here. Screen sharing.
Maybe if you can paste it in chat, that'd be great.
No, I can't do it. I'll just put it in the chat. How about that? TPW coming up in the chat.
Cool.
But yeah, TPW is a really cool psychedelic loop of moisture that is, I don't know, I guess satellite sensed for the entire Pacific region, and it's super interesting to see. And you see all the systems and all the moisture, and you see the wet parts and the dry parts. And if you see a dry part coming towards us, that's great. Yeah. So yeah, any questions? That's my basic base. I think that's my basic layout. Oh, another thing is in terms of precipitation, lately I've started to look at Windy has rain models predictions, which I don't know how accurate that is, but it's kind of interesting because we never really had a way to imagine, like, well, where are the showers going to be today, and it actually does throw up some modeled showers that are going to be wafting through the islands at different times. Haven't really done a lot of checking to see how accurate that is, but it's interesting to see. At least I feel like if I see that Windy is calling for some scattered showers, regardless of the actual positions and how accurate that is, that's something to show me that, okay, it's going to be a rainy day or it's going to be a dry day. I can at least verify that. But mainly I look at like the discussion in terms of moisture, the discussion, and the zone forecast for how they're laying out how the moisture is gonna pan out. And the other factor that I feel like is a huge factor is cloud base. We're always very interested in knowing like how high the cloud base is going to be. But honestly, I know I'm going to fly a given day, whether or not the cloud base is awesome or terrible. So I don't worry too much about it. The way some people, like if they have like one day off, they might need to predict, okay, which day is the cloud base really going to be good so we can go somewhere and have some fun. Whereas I'm going to fly all those days, and I know that, so I don't worry too much about it. But I am interested, and I will look at some predictions for cloud base, like try to figure out the skew T and figure out where it predicts the cloud base is going to be on a given day at a given place, or look at the virtual soundings on Windy. And I look for real-time cloud base is pretty important. I look at the traffic cams for Kaneohe generally to see how high clouds are over the Ko'olaus. That's a good tool. Anyway, yeah, I think that's it.
It's not it, Alex. How about so in the winter when we get the fronts coming through and it's not like the normal trade kind of pattern, and then
right, okay,
how do you decide like, oh, which of the various options am I going to consider?
Right. So that's not it. So
for our visitors.
Yeah, right. So that my general approach is still in effect, but I am looking at, we know in the summertime we have prevailing trade winds. The high pressure to our northeast sets up pretty predominantly, and we have trade wind patterns for maybe 70% of the time. And then in the wintertime we get cold fronts and low pressure is coming down and rotating our wind flow in a lot of different directions. And so I'm still using the same tools, but I have to, based on just, experience, I guess, I know if if it looks predicted that the wind is going to flow from the south, which is a prefrontal condition that we almost always get. If it's if it's the exact right flavor of south, we want it basically 10 to 15 due south and not too far off a due south, then, and not super stormy rainy, then we'll probably be flying Diamond Head. If it's a more light south, then we get a sea breeze situation, but that's sea breeze is a lot more complicated. Not going to talk about that yet. But so basically, surface wind is going to dictate where we go, and as these fronts come through, they will crank the wind from the south as ahead of the front, and as the front passes over and past, the wind will generally rotate from the west, and then from the north, and then from the northwest, and then the north, and northwest, then north, and then back to northeast trades. And we really get, like, if a front moves in a nice sort of slow enough pattern, we get a day or so of each wind direction, and we end up pretty often flying Diamond Head and Kahuku Motocross 2 days in a row, because that's the pattern of the frontal passage and the changes in the wind flow. And maybe the knob, Dillingham, somewhere in between there as well. Yeah, it looks like we might actually get some light north as the current front that's passing over right now, and wrapping up our Diamond Head days of fun. We're going to be looking at a possible knob afternoon tomorrow if it's not too rainy from the lingering moisture. And then it's going to crank lightly from the east, it looks like, as the trades try to make a comeback, and then another front, and then really strong trades coming after that. But yeah, I don't know. Does that sort of answer the question a little bit? The other scenario is sea breezes, and sea breezes is probably the most complicated scenario, because you could fly a lot of places, but most of them aren't going to be that good, and so that's a little trickier scenario. If you're just looking to fly, you're going to be able to fly on a sea breeze day, but how good it's going to be, and what you want to do with that sea breeze is kind of a question that Patrick and the guys have started addressing lately, way more than we ever used to.
Hey, Alex, I wanted to pick your brain on, is there a preference for pre or post frontals? I know some pilots always mention, like, oh, it's a prefrontal, and they get really excited. Is there anything like that here?
Yeah, there is. I would say, historically, anecdotally, and from what I've read as well, it backs it up. But everywhere in the world, I think post-frontal is a dream. Prefrontal is generally stormy and weird, and that's we fly Diamond Head, which is nobody's idea of an epic cross-country flight. But it's cool that we have an option for prefrontal, but it's always post-frontal that people get excited about, and it applies here too. I think the post-frontal atmosphere is always nice and dry. It gives you a high cloud base. It gives you a really nice lapse rate, and we've had epic flights on our post-frontal days.
Awesome. Thank you.
Yeah, I think those are the ones to look forward to, and they're generally like light north, northeast. They give us a good shot at some fun places to fly. I remember some post-frontal days, where we had light northeast flow set up at Kahana the day after the front came through, or the day after, because first it hits like North Shore, but as it came around to the Kahana side, super, like 4,000 foot cloud base, and just the most incredible lapse rate, one thermal from Rhino Horn up to like $4,000, and then you're just like, well, wow, I guess I have to go to Makapu. And those are the couple days I went to Makapu was perfect post-frontal days. It was so easy, you just turn and go. It wasn't even thermaling. It was just like lift everywhere, incredible lapse rate, and high clouds. It was crazy.
That's awesome.
Look forward to more days like that.
Yeah. One more, I guess we're going to get into SQT, right, Patrick? I was going to say, is there any tips since Kahana is your expertise on detecting Kahana Coolie days? Because we all love that, right? And it's a really nice surprise when we weren't expecting it. We get when I say Kahana Coolie, I mean a really nice thermic light Kahana.
Yeah, no, I think to me that the Kahana Coolie days are just a side effect of flying at Kahana on days that are lighter flow than we ever used to fly. You know, we used to need wind. We used to think, oh, we need some actual wind to launch and stay up. And in recent years, I think we've found that we need that less so. And so we'll go out there on days when we know it's going to be very light, and even if it's stable and sea breezy, it's very possible to stay up and get yourself into a little lee side air where you can get some kind of thermal cranking up, and then you're up and in the game and going somewhere. And it's interesting. Yeah, it can be rock and roll. As you know, we've had some super rough, strong thermal days at a lush green place where you wouldn't think you would necessarily get that kind of air. You'd think that's a Nanakuli situation, but that's why we call it Kahanakuli. Anyway, that's yeah. How to know when we're going to have those days? Just the lightest days that it's viable. Those are those days, I think. Lightest wind.
Awesome, thank you.
Cool, thanks, Alex. Yeah, we'll open it up for more questions if folks have kind of at the end of the presentations. But I asked Jack to talk a little bit about kind of what he's been up to on the west side the last couple of seasons. Because he lives out there and he likes that kind of flying. He's been kind of probing and checking out, I would say, more the margins of what we would classically say are like the good west side days. So I'm curious to hear kind of what he's learned and get it on tape. So
Cool.
yeah, Jack, let's
Yeah,
hear it.
Patrick, let me ask you a little about the format. Did you want me to go through the workflow or just my experiences?
Yeah, whatever, man. Talk us through your
Okay.
process, and then specifically, because I think you're doing it more than anybody right now, is like flying away, like this, like you're basically like our current version of Doug Hoffman, who would, you know, he told me and Alex has told me would just go out there all the time and fly it on the west side whenever he could, regardless of kind of, you know, if it was
Oh,
a
that's
great looking forecast or not. And so you've been doing a lot
Yeah.
more of that kind of stuff and learning a lot and kind of learning, I think that there's a lot more potential than what we would normally say based on
Yeah.
like, oh, that's like a classic day or whatever.
Yeah, cool. Thanks for setting the stage. And I think of myself as more of a human wind dummy when it comes to west side. So I mean, just to set the expectations, I mean, I live fairly close, and I really I come from a XC background, right? Probably very like similar to Boz, where coaster soaring is a luxury, and for me, I'm always seeking. At least when I started getting good, I was always about XC, right? So for me, that's a special thing, and that motivates me to do it. And that's not going to be true for everybody. So you know, remember that context when I go over the risks that I take out there, and then the shitty air that is almost always guaranteed that's on west side, right? So I start with the workflow. I know Alex talked about it. I know we all barf at blend. So I look on the wind alert, and I look probably a week out, and the caveat is we know that it can change on a dime, right? So this is just to plan around your weekend or whatever days you have free. Just have an idea of what days might swing into
Yeah,
a
okay,
good
can you turn your
forecast.
video on? And like, unless you're naked or something.
No, one
No,
second.
okay.
I have to do all the permissions. Give me just 2 seconds.
Yeah, or if you want to screen share and stuff too, because I don't know if you have any of that stuff. Yeah, cool.
There you are.
Hey,
I
right
can't
on.
see it. Well, I hope. Okay, anyway. So what was that? Oh yeah, the workflow is through the wind alert. So we look out about a week, and then as Alex and Patrick already said, wind alert WRF I've found to be the most accurate. It's not perfect every time, and there's some weird days where I don't know, you guys can talk about it, but there's some weird days where it's just ridiculously off, but it's 95% of the time correct. And what I would do is a couple days out, I see a couple, y'all say like, oh, you know, let's look 2 days out, 3 days out, 1 day out, whatever good days look good. And when we get closer, we look at the wind map. I can't share my screen right now, but this is the discussion Alex and I had on the progression chat. Is you want to look at the holistic view of the map, and the arrows showing you the wind speed and wind direction really give you an idea where the convergence will be, and it gives you an idea of the environment that you're going to be flying in, right? So what we're looking for is basically, well, I prefer low winds. You can fly in higher winds, and you can look for where the lines sort of converge, and that's typically where the convergence and also the overdevelopment possibly will be, right? So you're looking at that, and you want to make sure you have a time series. You can see the land breeze early on in the day flush out based on the model, and then just get an idea of what you'll see between 10 and 4, right? So just just to get an idea, picture of the day. I like point forecast after I've done that, because point forecast gives me a clue of cloud cover, which is really important for sort of getting an idea of the kind of day it's going to be. As you guys know, everybody here, these cloud cover tends to dampen thermals, right? But west side doesn't care. You can have overcast and still be working perfect, but it'll give you an idea if it's going to be strong or super strong, right? And then precipitation, I don't know, maybe someone here can explain, but the WRF precipitation model is fairly good at giving you a clue if you're gonna. I mean, we should all be looking at rain radar, and our eyeballs, obviously. But sometimes when I see those little green dots for precip, that gives me an idea if there's going to be a wave of rain coming in. So that's my initial workflow. And then I know, Patrick, you're going to talk about SKU-T and Fly Marshall and RASP. I jump over there and have a look at that. And one of the things I'm looking for is, because a lot of times you guys talk about flying the wrap, if the SKU-T wind models match the WARF on the wrap, that's usually a pretty good bet. And if I'm desperate enough, the RASP will not match the WRF, but I might still fly the wrap anyway, right? So that's something I'm usually looking for the west side.
When you,
On
when
the
you say
SKU-T
wrap, sorry, just to interrupt,
Mhm.
just to clarify, when you say
Yeah.
wrap, you're talking about like a Medio wind that's getting split by the island and then coming back together on the other
Yes.
side.
Yeah, let's talk about that for a second. So it seems like we are categorizing our weather forecast into a few things, right? We got sea breeze days, we got trade days, and we got, I guess, non-standard days, front, post front, north, south. I generally speaking, if you have a medial wind, you can visualize it like in a rock in a stream, right? So anytime, let's say a trade day. So I will fly. It's not 100%, but if it looks good, I'm tempted to fly Nanakuli when the trades are light, because if the models all show the wrap to be acceptable, it sucks taking off because it's just really bumpy. But if you get to the other side of that Waianae range, it's butter smooth and that base is high. It's a trade-off. But if you visualize the let's say a trade day, you visualize the island blocking the air, you see the wrap come around. By wrap I mean like the lee of the winds, and it's really obvious in the map. Now you can actually have the opposite too, right? I think just what day was it? Alex and I were flying that day. Like 2 or 3 days ago, I was at Makaha. It actually had a wrap convergence over Kahana, which made sense because the wind was coming from the south, right? Because if you visualize that, it's like reversing a trade wind wrap. So I was actually tempted a little bit to go explore that. So you can see that in the WRF model map. So that's what I mean by wrap. So it doesn't have to be sea breeze days. It can be, and again, take this with a grain of salt. I've tried it on days where it's like trade days where Kahana was at 10, and it was absolutely awful. 10 miles an hour and higher, it's absolutely awful. But sometimes it's acceptable at, like 8, maybe 8 at most. You can get away with that at Nanakuli. And then, okay, well, that's pretty much it. After that, if it's serious, if it looks like it's good, talk to your friends, talk to Alex, talk to Pat. That's actually one thing. And then you look at the SKU-T, and then there's a couple of things. You're looking at the lapse rate to see how strong the thermals are going to be. You're looking at overdevelopment potential. That's the one that really scares me, is OD potential, right? It tells me where it's going to look dark and gray and scary. And I found it to be fairly accurate, actually. Out here, the RAS is pretty good for that. Whether or not it actually develops in the ring is a whole nother story, but in my mind, it's like where not to go at a certain point in the flight. And then, of course, one more thing to look for, I know Patrick's going to talk about it, is all the wind shear and then the velocity changes at altitude, which is really important, because a lot of times I'll just end up flying and forget to check that, and then just hit just really uncomfortable air once you get hot, right? So that's my workflow in a nutshell. Any questions, Patrick or team? Anybody want to bring up?
I figured, yeah, we'll go deeper into the SKU-Ts, but I was curious what like the trademarks of true overdevelopment are on a SKU-T. I feel like it'd be helpful to look, you have the standard, like, oh, the two lines are together, there's your cloud base, right? Is it like the two lines stay together up to altitude is indicative of OD?
I think Patrick's
Jack was talking about
the slaps, right? Yeah.
Oh, so go ahead. I think Jack was talking about the RASP OD indicator, as opposed to the SKU-T.
Yeah.
Okay.
Yeah, that one does the computate. I wish I could share it, but there's a field you can say OD potential greater than 0. But Boz, there is, I learned this so long ago I forgot. But if you you should be able to project the temperature of the air in the lapse rate, which is like the bottom right to top left, like curved line. And if that intersects your, I'm trying to remember, your temperature in such a way that it's gonna basically condense the whole way up, that's gonna turn into a giant thunderstorm. That's not very descriptive, is it? Patrick will, if Patrick can share a screen, I think he can show you some examples of that. But there's a way in the SKUT that will show you it's gonna be nasty versus just fine, right? So yeah. So who's sharing? Patrick? Okay, yeah. If you go to Patrick, can you go?
Okay, I want to make sure I was unmuted. Yeah, here, I'm gonna share the RASP. Share, and then we go, so you have like, you can choose your date like up here, and then you can choose what parameter you want to look at. So I think Jack was talking about like OD cloud or OD potential, this one.
OD potential is not very useful because it just tells you the cloud base, but where OD cloud base, where OD potential is greater than 0. So in my mind, I have a map. Like for me, I'm like by 2 p.m. the valley is going to be not great, and then Schofield is not going to be great, and North Shore is not going to be great. So that's like sort of what I have in my mind, and I found it to be fairly accurate. It might shift by a few hours, but it's more or less correct most of the time. Of course, you know, with these things, it's never perfect, right? So. But this helps you plan, right? Because if it's like, oh, well, the valley looks like it's going to OD potential greater than 0, you either have huge balls and you go anyway, or you just don't plan to cross the valley.
Yeah, and yeah, I'll share Boz some of the OD stuff from this QT and the forecast soundings in a minute. So Jack, let me just process if you've answered enough of my questions. So talk about your process. You've talked about, so I would say as far as expanding the limits of what we normally can, like, so the classic West Side day is either nil wind, so it's only sea breeze, or maybe a little touch of like north is kind of okay. Touch of southeast is kind of okay. West actually tends to amplify the sea breeze, I think, and it's kind of, if it's actually west wind, that's kind of worse, because then it like the Medio and the sea breeze join hands and make it like stronger, like down low. But then you've been kind of checking it out more on like the trade days, relying on the block, right?
Yes.
So do you want to talk about blocking and what that is?
Yeah, so blocking is where the mountain ranges, or I guess the landmass and the thermic activity, right, put a block, as the name indicates, on the medial wind, so it wraps around. So it gives enough of a protected bubble so that the thermals can draw in from the east side or west side, sorry, and then you can take off. It's almost like you have a headwind. It's actually kind of nice. Once you take off, of course, the problem is that bubble is not infinite in size. At some point, that bubble ends. You get high. You now have the problem of where your medial wind is hitting the thermal block, and your sea breeze wind might not even be in the same direction, right? So you basically have wind shear at a certain altitude. And it's never clean. It's not like, oh, when you hit 3,000 feet, this is going to happen, right? It depends on terrain, depends on heating, and a lot of times the clue that you'll get is if you look at the clouds over the west side, you'll see how they're shearing and where they're drifting as they. When I say clouds, I'm not talking about like high level clouds. I'm talking about like the cumulus that form, and that'll give you an idea of how sheared or how protected it is. There's times when it's completely acceptable, like bumpy, and there's times when it's just like I don't want to be flying this. It's really hard to tell because there's days where I think it'll be fine, but it turns out to be like I'm having zero fun, and days that you think are going to be stronger that are perfectly. Patrick, you know this. So it's something that you just have to sort of like, you get kind of a clue looking at the clouds and the winds, but you really don't quite know until you're up there. One thing that we learned is that it kind of makes sense if you think about it, is you don't want to hang around Nanakuli. You don't want to hang out where it's brown and the thermals are booming. We usually get as high as we can, what's the word, put up with. And then we start, if it's safe, we start pushing toward the back range because it tends to smooth out. I usually try, if it's safe, to climb all the way to the east facing side of that range, and all those problems go away on wrap days. It's just beautiful and nice usually if you can get there, which you typically can, because west side for me, between like in the mornings, like between 11 and 2, is almost always working. I know you guys probably have days that it's not, but it always seems like every time I'm out there, it's not a question of whether or not it's not working. It's a question of whether or not safe. So. As for other days, I think I agree. South, I've had zero success. I'm like 0 for 2 or 0 for 3 on South days. They're just horrible. And then West days, like you said, it's like, hey, this should work, and you get up in the air. It's usually not that fun. So, but West days is one of those things where I think it has potential. I think I've been talking to a lot of guys about this. Is we should be able to get off on end of the world Kayana Point on a West day, and then figure out what Theo and Pat did, or not Theo and Will did, going through Mount Koala. So that's something that I'm like keeping an eye on for a nice day to try that. Like a westerly, like a west southwest kind of day, just to explore that area.
Cool. Anybody want to pepper Jack with some clarifications or any questions about what he just talked about?
No, I wouldn't mind adding just one idea, which is kind of random and maybe not directly related to what Jack's talking about. But I remember a day, maybe 2 years ago, Matt Senior and his crew were here, and it was clearly a northwest flow day, which to me, I got excited about KMX because I love that place. But somehow, because Marcel was fired up about Nanakuli every chance he could get, he's like, no, I told Maddie we're going to Nanakuli today. And I'm like, what? It's northwest. It's not going to be good. But actually, it turned out to be amazing. Mark ended up flying at KMX and having a good day out there. And I was still feeling like, oh, we should be there at KMX. We don't get that many days over there. And but instead we went to Nanakuli, and it was blowing very strong from the northwest, like pretty much parallel to the coastline. And some people went up to upper launch and got hauled off, including Marcel, and me and Zach were on the low launch, and we got plenty hauled. I mean, it was howling down there. But Maddie and Austin and I forget the other guy. Anyway, those guys ended up going deep to the back range, like Jack's saying, and it cleaned up. They got into some smooth convergence back there, and we're just like skied out at cloud base, and it was pretty high, dark sausage all along the Waianaes, and they flew all the way to into the world, getting higher and higher and higher. And then they could have come back or whatever, but they ended up just hopping off at the end to go land at Haleiwa where they were staying. But it was a pretty epic example of how convergence can work on a day when you might be thinking about a different place like KMX, but like that northwest flow really just like perfectly came down the range and allowed the wind to come up both sides of the mountains there in a way that was surprising. The funny thing is none of the Oahu locals joined those guys, because we were like, it was so strong and rough in the zones we were flying that we didn't believe them when they said, you guys, it's smooth and nice, come on and join us in the convergence. And we were just like getting our asses kicked up front and thinking, those visitors are crazy. Like, what are they even thinking? What are they doing? But anyway, just to add to the experience of what West Side can be. That was a pretty interesting day, and I wish I had taken them up on their invitation.
Cool. So Jack, you mentioned like some days, when you're basically in the lee, but it's acceptable because it's sort of blocking and you're using the thermals that are coming up the slope on the west side, and it's uncomfortable, but it's acceptable until you get high enough to punt over onto the windward side. What just for everybody, like what's describe like a acceptable but uncomfortable kind of day versus like a, oh, this is sucky, I don't want to fly here kind of day. Is it like because you're taking collapses, or like what does it actually look like?
Yeah, Patrick, I think because you've been with me over half of those days. So my metric is the climb sync. So I know you guys all fly a lot. When you get that, what really scares me is the big climbs followed by the big sink. That's the where it yanks you forward, and all of a sudden that dies. Because in that half second, if you take a collapse, there's no tension in your wing, right? So that's that day I flew, it was like 10 or 11 at Kahana trade day. It was just borderline. It felt borderline dangerous for that reason, right? I was like, well, if I get timed just wrong, I'm gonna lose my wing, right? So that's one metric. Another is you get tip collapses. That's sort of a warning because on our gliders, our tips are flappy and happy to collapse. So that's usually a warning as well. Bumpiness is a pretty good indicator, but that's sometimes you can have bumpy and be just fine, right? And the third thing is the shear, right? If you get up and all of a sudden, if the shear is really what's the word? Is all of a sudden you shift from like 180 from like let's say from the southwest to the northeast within like 50 feet. That's usually pretty concerning, right? So those are the things I'm looking for. And we're flying. I don't know. Maybe the more experienced pilots can tell me. I always feel like the D wings are hotter and less dampened. I don't know if this is always true than our C gliders and B gliders. So sometimes where I always feel like I'm crapping my pants and everyone else is like this is fine. So maybe there's something there that needs to be taken into account. So yeah, that's my metric. There's also the intangibles, right? If you just don't feel comfortable, some days I don't know how I can explain, but some days I just don't feel comfortable like going back there, right? And some days I feel like I can charge ahead, and that might be a function of how hungry I am or how often how I haven't flown enough. But I don't really know how to explain that. But that the main thing again is I'm really on edge when the takeoff is scary and when you get that big climb with a big sink. You're hearing about it like do do do, and you feel it, and then all of a sudden it'll be like nothing. That's usually when I'm really scared.
Yeah, cool.
Sounds
Yeah,
like
that sounds like
just
Lee
a
Rotor.
swirly gust.
Yeah,
Yeah.
cool. All right.
Block until it doesn't block.
Yeah, I can kind of take over the process and kind of the SKUT stuff if you guys are ready for it. So let's share our screen, the desktop.
A real weather geek.
Whatever. Share. And okay, what are you guys seeing right now?
OD
desktop.
cloud base.
The RASP. Okay.
Yep, the RASP. Yeah.
Let me close. Okay, so it shares like each window separately. So let's go back to this. Or I'll just kind of lay some stuff out and then we'll start sharing as needed. So my process is pretty close, I think, to a combo of Alex and Jack. I would say I look about a week out because of my work schedule. I work 3 12-hour shifts per week, and I have like if I really need to, I can hit somebody up for a schedule switch. So if it looks like amazing, like 4 or 5 days out, I can kind of start planning or kind of trying to switch my days around so that I can be off on a flying day instead of working. Doesn't always work, but I do have a little bit of a longer view, I would say, than kind of Alex is looking at, because he's a little more tuned up in the killing it flying every day department. But I'll start with the area forecast discussion for sure, and then for the kind of flying that I'm psyched on right now, which is kind of like learning new stuff and checking out parts of the island I haven't been before, or flying lines I haven't done before. And that usually involves either like something on the west side or something through the middle of the island. And so I'll use just Wheeler Air Force Base as my like point forecast for the National Weather Service. So here's the area forecast discussion. I guess I'll just share here. So let's pretend we're looking at the coming week, and I'll just talk you through my process here. So this is from, I think it's been updated since then, but this is from this morning, 10:15. So it says there's some fronts coming through. that are going to move down the chain, etc. Breezy southwest, and then by the middle of the week, we're going to have some light winds, and then a cold front Friday, bringing more rain later, etc. So I'll try to build a picture in my head. Are you guys seeing windy now?
Yeah.
Okay. So as I'm reading through the area forecast discussion, I will like take a look at what the big kind of picture is looking at on windy. So I'll maybe start back here. So here we are on today, and then I'll say, oh, there's a couple fronts coming, and I'll just tap. And this is the Euro model, the ECMWF. I'm like, where are these fronts? Oh, here comes one, the little blob over on the left coming, the purple blob. There's a front hitting us now. That's switching the winds up. Now it's Wednesday. There's some light winds on Wednesday. Okay. And the stuff's kind of, I can see what they mean about breaking up, because instead of like a big dark blob, it's like a little speckled blob now moving through by Thursday. And then Friday now we have looks like some strong north coming through. And then it's like nuclear by the weekend. So I'll try to match what the area forecast discussion is saying with what I can see on the actual, like the models, and see if it matches or not. And then I know kind of how reliable the models are going to be. And if you look at like the GFS versus the Euro, or the NAM versus the Euro, and there's big discrepancies, it tells you there's something that the certainty of the model is not that great. So the better the model, all the different models that you look at, the better they correlate, the more certain you can be in your forecast. So then I'll go back to, are you seeing now the National Weather Service kind of point forecast Wheeler? Yeah, okay.
Yep.
So because it's just like a nice spot in the middle of the island, I'll use that as like my point forecast for what the saddle's doing. And you can see, it's raining right now. Just obviously a couple days like jump out at you Wednesday and Thursday. So Tuesday, I know it's kind of looked okay from the wind point of view, just from looking at like wind and rain, but more on like the North Shore, because there's going to be a lot of moisture around, which is not a deal breaker. Scattered showers are fine. Like 40% chance of showers might be fine, depending on where they're hitting, if you're on the coast. But when you're flying in the middle of the island, I think we need like a definitely a drier forecast for me to feel psyched about like going in there. So it looks like maybe Wednesday and Thursday are potentials, just looking at here. So this is like, my week out, a few days out, 5 days out or so. So kind of the priority would be, wind and rain are like the two deal breakers. And then the windy model, or the windy.com, will give you a longer look than the WRF, right? So it's not as accurate for because the granularity is not as good. So the smallest model that's good for us on windy is the Euro, and that's like a 9 kilometer kind of pixel that they're looking at, versus what is it, 1 kilometer for the WRF?
Yep.
Yeah. So it's not as good, but for the big picture stuff, it's fine, and you can look like a week out. So then I've kind of identified like which kind of days might be nice, and if any of them look like they're potential XC days, then I'm going to start drilling in and looking deeper. And so I guess my definition of an XC day is like a day where you'll be able to leave wherever you launched and go somewhere, and maybe go somewhere new, and you don't know exactly what's going to happen. There's plenty of days that are kind of like XC, like up in the Kahana neighborhood, where you're bopping around and you might bomb out where you didn't expect it. But I'm talking more about the days where you're using the back range and you're using like the middle of the island, or you can use the Waianae range, like the back crest of the Waianae range. So then a couple days out, if a day is still looking good, meaning it's light wind for XC and the cloud base is acceptable and it looks dry enough, then I'm going to start looking at the surface winds with a WRF. And nobody actually kind of showed, it's on the phone, obviously. So does anybody not know how to get the WRF on the Wind Alert app?
You don't have to pay for it, right? It's free, right?
You have to pay to get the one that gives you, what is it, Alex? The Punaluu sensor, right? You need to pay for the Punaluu sensor.
Makapu'u as well, I think.
in Makapu. Yeah.
Yep, but the map I think is free, right?
Yeah, I don't know. I don't know who the map the forecast is available to.
Yeah, I think you do need to pay to get the sensors that we use all the time, but I'll just
You
pull it
can't
up.
see you can't see the WRF graph lines unless you're logged in. But you can see like the overall map.
Awesome.
So I don't know. You guys looking at my phone now?
Yeah.
So here's the wind alert app, right? So you go up, you go boop, you go forecast map, boop, and then you go, let's look at the model, the blend. Oh no, we don't want the blend. That's bullshit. So WAWRF down here, boop, back out, boop. And so obviously it's like nuclear strong right now, and then you can scroll through, right? And it'll show you what you want to see. And because it's so like strong right now, it's not that interesting. But you know, on a more sea breeze day, it'll actually show you like the wind pulling in from the North Shore and the wind pulling in from town. And then these little like light purple and white dots are going to be where your light wind is. And that's where your, you know, generally your convergences are going to be setting up. So that's kind of the wind alert, the WRF for your surface winds. And then the other thing that's really important for the XC, I think, is the stability. And that's like what to Boz's question, is the day going to blow up and be OD, or is it going to be okay? So you want to know that, and then the cloud base. And I think the forecasting soundings that's available on Windy are actually like pretty good for this. So I'm going to pull that up. All right, so you guys are looking at Windy again?
Yeah.
Yes.
Cool. So let's drill down, and we're just looking at the wind right now. We're looking for an XC day. We're just tapping through the wind. We know that Tuesday is going to be kind of wet in the morning, so we're not going to stop and check very closely. But we know that kind of later in Wednesday, it's going to maybe dry up a little bit. So we're like, oh, look at this. So we got some south flow. It's light. Let's kind of drill down a little bit. So light south, that could be for sure like launching somewhere on the west side. Oh, keel's back, admit keel. So if you go, there's a couple ways you can do this. You can go up to this little kind of like hamburger stat menu over here up top left, and you can do the plugins. So you go install Windy plugin, click. And I would recommend not doing this QT. It's actually not that great. You could go to the sounding, open the sounding plugin, which will probably take forever for some reason. Yeah, sweet.
Patrick, I've never done this on the desktop. I've used Windy on the phone app. Do you know if the sounding is available on the phone app as well?
Yeah, it is.
It is.
It
Yeah,
is.
it's just a
I've
different
used
way
it.
that you have to access it.
Yep.
Cool.
I could show you. It's, I mean, yeah.
Yeah. If you want to bump my screen share, Alex, mine froze up just now. So if you want to kind of show somebody with the camera, or like just hold your phone up and
Yeah,
share your
let me see
screen.
if I can. Yeah, so I mean, here's the, let's see, if you look at the map. Oh wait, we're on Windy now, right? Windy. So the Windy map, I got the European model by default here, but let's say for tomorrow, 3 p.m., if I hit a point, there's a menu at the top. I don't know if you can see it that says, where's my
I think
here?
your blur background is
Yeah,
blurring it.
it's messing it up. But anyway, there's a menu at the top that says sounding, and that's what you want.
Okay.
If you just click any point on your Windy wind forecast, and it'll give you the menu at the top of the phone where it says sounding. And if you click that sounding, then it shows you the sounding. Here, let's see the sounding. Come on, it's me, the sounding forecast.
That's awesome. I didn't know that. Cool.
So it's a virtual sounding, obviously. It's a forecast of what they think a radio sound balloon would give you
Yeah.
based on the computer
only
model figuring that out.
Yeah, the nice thing, there's actually on the mobile version of the windy sounding. Oh, Jason entered the waiting room, but my mouse is frozen, so I can't admit him. I might have to like reboot this. But the nice thing about the mobile version is that there's a little button that actually lets you look at just like a more proper SKU instead of like the little fake one that shows you the clouds and whatnot. And on that one, you can adjust like what you expect your ground temperature to be. So you don't just have to accept what the model's prediction of the ground temperature, which is going to tell you you go from your dew point on one side at ground level, and then you go from your projected ground temperature, and there's a little tool that lets you like set that stuff, and then it'll take you up and you can see where your cloud base is going to be. And then if that falls on which side of your environmental lapse rate, so you know if it's going to be cloudy or dry, and then how tall your clouds are going to be. By playing around with that ground temperature a little bit. So I guess I'm gonna have to see if I can close out my web browser, see if I can reboot this thing. So if this all goes to hell, then just stand by and I'll jump back into the meeting. So here we go.
It's for me to take an extra bite of dinner.
Yeah. Okay, we'll see what happens. So while my computer is doing its thing, you can still hear me, I presume. The forecast sounding is pretty much, I think, the best way to see the SKU. I tried for a while to find a way to actually see just the raw SKU from the National Weather Service. You guys probably already know the radiosonde balloons go up at Lihui and at Hilo twice a day at 0000 and at noon Zulu time, which is like 2 a.m. 2 p.m. our time. And so then you can have that data like shortly thereafter. But the only way that I've found to actually see it is by downloading some like meteorology software called like the Cave program. And then it's got this like tool with an abbreviation called NSharp where you can actually see like the raw SKU that's not like a model. But it's actually, I don't think there's a whole lot of value in that because the models are just grabbing that information anyway. And then, so if it's just, it only depends on like how far away from time-wise you are in the actual sounding to see like, how close your confidence intervals are. And there's enough variability anyway in just looking at the model and then knowing based on the fact that you've been looking at the model and then looking at the sky and looking at the model and looking at the sky over and over and over like dozens of times on all these days that you want to fly. And you get a pretty good sense of how it correlates. So let's say the forecast sounding is predicting our cloud base at 4,500 feet. And today the cloud base is at 3,000. And then today the model said the cloud base was going to be at 3,500. So you know that it was a little optimistic today. But if you know that we're in basically the similar air mass and that we're in like the same kind of weather system as the day before, then the model correlates really well. So if the model said 3,500 today and it says 5,000 tomorrow, 100% it's going to be a lot better tomorrow than it is today. It might not be 5,000, but it's going to be a lot better. And so you can still like use it as a planning tool. And so then if you know how high the base is, then essentially you need, like to fly XC, you need the cloud base to be like quite a bit above crest height, right? For it to feel comfortable going either like along the back of the Kolau, if that's what you're looking at, or if you're looking at launching somewhere in the Waianae and getting to the back of the Waianae, you want it to be above the crest height wherever you're planning on flying. The other thing that's super important is whether or not you're going to have a runaway lapse rate that's going to create the overdevelopment. So still don't have my mouse here. I'm going to troubleshoot this in a little bit after turning it over to somebody else or for some Q&A, but just to wrap up that point, there's a way where you basically, with if you have your SKU-T, it's just based on the lapse rate, what happens above cloud base. So if you have unstable air above cloud base, then the clouds are going to keep building, keep getting taller and taller and taller. And then you're going to have, really tall, dark clouds and lots of them and maybe rain. Versus if above cloud base, you have a kink in the environmental lapse rate such that there's a layer of stability or even an inversion, then that will cap the height of the clouds. And so you might have clouds starting at like 4,000 feet, but if there's a layer of stability at like 5,000 or 6,000 feet, then you wind up with this really narrow band of cloud that's totally not scary, and you can fly like anywhere underneath them, with your 45-degree rule, feeling pretty safe. And even if you mess up and you were to get pulled into a cloud like that, it's only going to pull you up 1,000 feet or a couple thousand feet until you get spat out. So it's not like you're getting pulled into like a QNIM where you're going up to like 30 grand and getting turned into an ice cube. So those are like the two biggest pieces of information that I use the SKU-Ts for. It's your cloud base, and then whether or not it's going to be stable above the clouds or not. So you have an idea of how the day is going to shape up. So if you're going to be flying around in the saddle, you definitely don't want to be having a lot of like tall clouds.
Are you looking at the tilt of the lapse rate as well on this QT? Is that something that?
Yeah, for sure. The other day, well, not the other day now, the last kind of blue day that I think me and Jack kind of went over the back at Nanakuli, and then I landed pretty early. I landed right next to Kania Road. I basically didn't get any other good climbs after I went over the back, and then Jack like hung on and flew to Mililani, and it was like pretty low most of the time. On that day, the lapse rate was shitty. It was actually like our temperatures, it was just like a cold day, and there was an inversion, which is why it was blue, because the climbs were topping out before they hit the dew point. Like those parcels were going up, and then they were bumping into an inversion before they got high enough so that they turned into cloud. So it was pretty blue, but even in addition to that, our ground temps were just low. There was like this kind of weird, like orange, like a lot of particulate matter in the air. And so the solar energy wasn't that strong hitting the ground. So the ground temps were low. And so the climbs were just like, blah, they were just really slow. Like if you had like a half meter a second climb, you're psyched. Like that was amazing. Like just, climbing up like at the back of Nanakuli. So that for sure makes a difference. And I used to think that, like speed to fly was not an issue for doing route planning on Oahu, because we have such a small island. And in the last like season or a couple seasons, I've totally changed my mind about that, because we can't usually get going until like 10 or 11 at the earliest. And then if you want to do like a big flight, you might, it's going to shut down, because we're usually flying in the winter. So it usually shuts down around like somewhere between like 3:30 and 4:30. Just the climbs are just not there anymore. And if there's any wind, your climbs are not going to get you high enough to overcome, if there's any kind of sea breeze that you're going against, trying to get somewhere, you're going to be like on a treadmill, just climb, 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 climb. You try to glide, climb, 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 climb. So it's got to be like a really kind of light wind day to make progress late in the day, or just like an exceptionally like perfect XC day, which I would say is like a strong lapse rate down low where you're launching. You want to be able to like get something and get up, away from terrain quick. And then at above crest height, though, you want like some kind of layer of stability to keep the clouds in check. Because if it's just like blowing up everywhere, then like, you might launch Nanakuli, when there's just like a single puffy queue over that front peak. And then by the time you get up to it, you can see that the back is already like starting to thicken and consolidate. And you don't even want to go back there anymore, because by the time you get back there, it's going to be just like thick and tall, and it's just scary. You don't want to get like hoovered up into stuff.
Or rained on.
Yeah. So I'm gonna reboot my whole system here. If you guys want to fire some questions or just talk amongst yourselves for a while.
Just a side note. I don't know if this is what you're referring to, but I do have a web version of the Lihue QT or the Kona QTs that you can pull up without having to have any fancy software to view them.
Cool.
I can post that link up in the chat. It's just it's basically the only visual representation I'm aware of that comes available as soon as they send that balloon up.
Nice.
So that's available as a link on your mobile, which is pretty handy if you want to look at it.
All right, I'm trying to reboot my stuff. If I somehow like kill the meeting, I'll just restart it, and we'll all have to jump in again. But hopefully, it'll just like boot me off while I'm trying to get my computer going again here.
Quick question on the soundings. Where do they launch those balloons from? You said it's on Big Island, or do they do one here too?
Yeah. So both of the balloon releases are 100. What the heck? Someone just put a thumb on me. I don't understand this. There's Zoom meetings. Yeah, there's two places they release, and they're both 100 miles away. So they're pretty far from our atmosphere. And you could choose Kona or Lihue, but I choose Lihue because I feel like Kauai is generally going to be, even though it's equally distant from the Big Island, somehow it seems to share our weather patterns closer than Maui and the Big Island. So they kind of in the forecast discussions, they kind of lump Oahu and Kauai, the Western Islands, together. And I feel like if we're going to look at a sounding, I don't know, that one seems more close to what we're going to get.
Okay, cool. Yeah, that makes sense. Yeah, I was thinking sounding for a Big Island, like their weather can be so different from ours on any given day.
Right. Yeah.
Yeah, I agree. I look at the Lihue one mostly, and I suspect that the models are just grabbing whatever, right? But I suspect that the Lihue one influences us more than the Big Island.
Yeah, so I guess that was gonna be my follow-up. If those are the only two balloons being launched, like anything else we'd be looking at is just a computer model of what they think.
Right. That's right.
But here's another thing though, is that's the case. Oh, maybe it's just my trackpad. Okay, sweet. Back in action here. Everywhere in the mainland is in the same situation that we are, unless you happen to live right next to where they're sending the balloon up. So like if you live in Oakland, you're stoked because they send the balloon up from the Oakland airport if you're flying to the Bay Area. But if you're living in like LA, I think the other balloon in California is like out of San Diego or somewhere. But if you're like somewhere up in NorCal, like you're hundreds of miles from the next balloon sounding. So everywhere pilots have the same issue that we do, where we're not like right next to our sounding site. But I think we actually have an advantage in that there's not a lot, like the weather comes from the northwest generally and then drifts down to us. So it basically comes from Kauai, drifts down to us. So if you get a sounding from, Lihue, it's going to be coming down to us, whatever's going on up there. Versus like a lot of places in the mainland, that's not the case. They might not have like their weather systems coming from the same direction as their sounding. But I found, like I said, like the models like do a pretty good job of figuring it out. So, all right, let's see if I can share my SKUT stuff. Stop that and start this. All right, so you guys are looking at like the whiteboard here.
Yeah.
Mhm.
So we're not going to get into like what is a SKUT, but in general, this is I've taken out most of like the isotherm lines and just to make it a little clearer. But let's say we're looking at this is like I would just put like for on the windy sounding forecast tool, I would just put my marker somewhere right around like Wheeler Airfield if I want to look at what's happening in the saddle. And I would choose like, I look at a few different times during the day, but like noon is a good one. And then you want to look a little earlier and a little later. Usually the heat of the day, the highest temps are kind of like early afternoon, and that's when you're going to have the highest cloud base. So, Boz, so your question of how do you know if it's going to be like unstable versus stable? So some things doesn't matter what the day is, are always going to look the same on your SKUT. So your isotherms are going to look the same, right? So, your x-axis basically is your temperature. So it's called a SKUT because the lines don't go directly vertically; they're skewed off to the side, and they're actually not like perfectly straight either. They curve gradually. It's like a logarithmic scale. But if you're just zoomed in tight, then they all look straight enough. That's why I drew it this way. And then your y-axis is your altitude, and on most SKUTs it's listed in like pressure, like hectopascals, which is like millimeters of mercury.
Super hard to interpret.
Yeah, but the model, like the dummy tools, the windy tool will have like an altitude conversion, so it's not that hard. So what you want to know is, all right, where's the cloud base going to be? And like I said, on the mobile tool, there's a little way that you can figure this out. If you're just using the desktop version, it'll just pick a ground temp for you based on whatever forecast it's pulling its data from. So let's say, the forecast temp at like noon is like 82 degrees on the ground. So that's where I put the green DLALR line right over here at 82. And then this red line is like what the actual, like if you were to launch a weather balloon at Wheeler Airfield, this is what Windy is saying would happen as it goes up through the atmosphere. So it's going up, right? The air is getting colder, colder, colder. But then, oh, look at this, like right around here at like, say 5,000 feet, what's going on here? This is where it's getting more stable and the air is actually getting like a little warmer as it goes up, right? And so that's like, you could, depending on how warm it gets, if it's actually getting warmer, then that's an inversion. If it's following, I didn't draw these parameters right, so don't. Basically, if it's still getting a little bit cooler, but not quite to the isotherm, then you would call it like relative stability. If it's actually running along the isotherm, like it doesn't change at all, then it's isothermic. And if it's getting warmer as it goes up, then it's inverted. But it doesn't actually have to be inverted for it to stop the development of clouds, right? Even if it's just like pretty stable, that can keep the clouds from getting too tall. So you take your dew point on the ground, which is over here, and then there's this magical line called the saturation mixing ratio, which is essentially like if you take your hot parcel of air over here, right, which is like going to be your thermal temperature as it rises. We're not actually looking at the dew point of the environmental column of air that was sampled. We want to know what happens to this like hot thermal air as it goes up. Where does that hot thermal air get cold enough to turn into cloud? And that's where this like saturation mixing ratio line comes in. So you start that thing from your dew point on the ground, and then it's just a constant ratio of like basically how much water can that air hold as it goes up. So it's essentially like the dew point of your ground air, which is what your thermal is as it goes up, right? It's ground air that's then gone up super high. It's not the environmental air that's just floating around up there. And so that will tell you what your cloud base is at. And then once your hot parcel of air has hit cloud base, it's not going to keep cooling at that dry adiabatic lapse rate because it's not dry anymore, it's saturated. So then it becomes the saturated adiabatic lapse rate, which is this like dotted line here, which cools slower. So depending on where your cloud base is, on which side of the environmental lapse rate, that's going to tell you if it's actually cloud or if it's going to be a blue day. So if we had the same ELR, but our DALR met the, what would have been the dew point like over here, then essentially what would have happened is that your thermal is going up, boom, and it hits it. It's the same temperature here as your environmental air before it ever gets cold enough to turn into cloud. So there won't be cloud, it'll be a dry day. But this day has some cloud, right? So here's our hot thermal going up the DALR, boom, it hits the point where it starts to condense. So that's the cloud base, but it's still not the same temperature as the surrounding air, right? Which is the ELR. So it still goes up at the SALR rate. And all the while, this whole level of altitude becomes cloud. And it's only once that SALR crosses the ELR again that it stops becoming cloud. So this would be like a really sweet XC day because you've got this cloud layer between like, 6K.
The base at 6K. Damn.
Right, which I've only seen like once where I've been flying. And then it's only a couple K deep, right? So it's like some flat, nice clouds, marking lift that are not scary at all. So versus if you had, we can erase our ELR and say, what would happen if the ELR actually kept going and didn't have that layer of stability in it, okay? And that's what we're looking at for the overdevelopment.
Quick question, Pat. Can we go over where the DALR saturated lapse rate are on the flight marshal at some point. Not right now, but
Yeah.
okay. And my other question was, we're kind of taking a guess on what our thermic temperature is going to be, right? Obviously, if it's like the side of a black rock on Nanakuli is going to be kind of hot. So that's sort of where that DLR at 81 degrees in your example, right? I mean, obviously you can have hotter air than that or cooler air
Yeah.
than that, right?
Yeah, and you're taking a guess on what the ground temp is, and the model is going to do that too. So if you plug in like Nanakuli versus Wheeler versus Kaneohe, the model's going to look and say like, oh, what do I think the ground temp is, right? And it might be right or it might be not, but it's usually correlates pretty well with what we actually see. Like we always have higher base in the saddle because it's drier and hotter in the saddle than it is like in Kaneohe. Right, so whenever you're flying around in the saddle up at like 5K, you're looking over at the Ko'olau, and it's like the cloud base is often like down below crest height, even though you're like 2 grand above like where the cloud is over on the other side of the range. But one thing I used to obsess about that, about like, oh, the ground temps, there's all these different heating surfaces. So like, how can you say what the ground temp's going to be? Because you might have like this hot cliff face that's like 100 degrees, but that doesn't actually result in cloud bases that are that different. Like at base, it's not like you're up at base and you see like one thermal that's going to like 6K and one thermal that stops at like 3.5K. Like all the thermals kind of seem to stop at the same spot, right? More or less, like their cloud base is pretty consistent. When you look straight across the sky, it's not like you have like tons of different clouds all over the place based on where the thermals were born from. So overall, like it actually, like it kind of works out. Like it all sort of like shakes out, and by the time they actually turn into cloud, you do have like a pretty consistent, flat, even cloud base based on like what the ground temps are. Because I think, as the thermals are coming up through the air mass, it's not just that cliff face anymore. It's been entrained with all kinds of air. It's been entraining cold air. It's, from like the gulch over here. It's been entraining the suburban like subdivision over here. It's been entraining the roads. It's been entraining the bushes. And so by the time it gets high, like that thermal is a pretty good average of all the different ground temps. That's my theory. Anyways. So looking back at our now our new lapse rate, the ELR, it stays in an unstable configuration like all the way high, right? So now instead of having a low, like flat from like 6 to 8K, this whole area between, here's your saturated adiabatic lapse rate. This is like what your air that's now cloud is cooling at. So that's like one end of the spectrum. And then this is the temperature over here of the other end of your clouds. And this whole area in here is going to be cloud. And so that's what overdevelopment looks like. And that's what they call the acronym is the CAPE. It's like the accumulated blah, blah, blah. It's basically like the potential energy of the atmosphere that can blow up into like, tall cumulus and eventually thunderstorms. So if you see, you're looking at your forecast sounding, you see an environmental lapse rate that's just going ballistic all the way up, past cloud base and way above, that's not, to me, that's not an XC day. You're not gonna be able to use the back range of any of the ranges. You're not gonna be able to use the saddle because it's just gonna be too scary. And usually on these days, by the time it's like 10 a.m., there's already like thick cumulus just like congealing all over the place. So any guys, anybody want to ask about this stuff before I pop over to the RASP?
That was super helpful. Yeah, I'll just say that. Super, super helpful. Thank you.
Thank you. There is a general rule of thumb on if a climb is going to be strong or not based on that day you circled and you said science, and I'm trying to remember because we were complaining about how strong it was at Kahanakuli that day. It was if the temperature drops rapidly given altitude. What was the rule of thumb? There's a rule of thumb for that, right?
I don't know, but I don't know what the rule of thumb is, but I just remember like looking at that day on the forecasted lapse rate was like super flat. It was like ridiculous. We're like, holy crap. Meaning
I think that's what I was going.
Anything that rises off the ground was going to have this huge temperature difference between this like very rapidly cooling environmental air as you go up
Yeah.
versus like the parcel. And so that parcel is just going to be shooting up, like super fast.
Wait,
And those
can
are
you
the
help me?
days that
Yeah, sorry to beat this to death. Can you in this example, can you visualize that? So the DALR will be much more
DLAR
vertical.
no, the DLAR,
It's the
it's
ELR.
always the same. So the DALR is always the same
Okay.
rate. That's a degree Celsius for every 100 meters you go up.
Okay.
That never changes,
Okay.
right? And that's what our thermals do because they're hot air at the ground and they don't mix
Right.
with the surrounding air as they go up. So that's the DALR. That's how fast that stuff cools. But the ELR is what the sounding is actually measuring, right? And so if you have like a crazy lapse rate, it means that so if you're just looking at my little pencil here, this would be like a pretty strong lapse rate. But if your lapse rate is like barely colder as you go up than the DLAR, it's going to be like pretty slow climbs. But that day that we were talking about, it was like almost flat until you got to like crest height. It was going out like that. And we're like, oh my gosh. And sure enough, like it was pretty wild. Like I don't think I flew that day. I think you guys were reporting that it was.
Yeah, basically, the more the ELR is tilted laying down, the more nuclear the lapse rate's going to be, and the more it's like straight up, the more stable and lame it's going to be.
Correct.
Yeah. Cool. Thanks because I had stopped looking at SKUT at that point because it's always working on Oahu. Anyway.
Right. So let's take a look at the RAS. Oh, that's not it. That's that cave tool I was talking about. Let's close him down. I want to look at you.
If I remember correctly, what happens with dew point intersects ELR? That's just normal clouds, right? Not non-thermic clouds.
You're gonna have cloud and rain. If your dew point, so not your saturation mixing line, but the actual dew point is the same as the air. All that's saying is that the air is the same temperature as dew point, which means it's wet, it's cloud. And if it's low, it's fog. If it's high, it's cloud, and you might have a lot of rain. So if you have like the situation in which your ELR and your dew point are going like up like that together, it's just cloudy, like thick, congested cloud.
Got it.
I think I had to close down my Chrome here. So let's go to our RASP. And that what I've used the RASP for is the convergence is nice, and then just looking at top of lift is actually pretty nice. So let's look at Wednesday. I think that was the good XC day. So I don't really use it for the wind parameters because the windy gives me the winds aloft pretty good. Like the Euro model is actually pretty good. And you want to see lighter winds aloft than you do down low. Because if you have stronger wind as you go up, then you're going to get those shears that Jack was talking about. And you can't rely on the fact that if you get to a back range, it's going to be nice. Because on a sea breeze day or a light wind day, the mountain ranges are going to block. And so on top of the mountain range, those are actually what's drawing the air in. And so you generally have really light wind and it's pretty nice right above the crests. It's like of the Waianae or the Ko'olau. But if it's like the Medio wind actually increases as you up in altitude, then that is all out the window. And you can wind up, let's say you're at like 3,500 feet over the Ko'olau and you hit strong wind, you're like, shit. And then all of a sudden you're getting blown over, and then you can have the situation where you're in rotor and all kinds of gnarly stuff. So we like to see lighter wind as you go aloft. And sometimes I'll just confirm that with a RASP that it matches the other models. But I'll look for the top of lift, which is where is it? There's a height of critical updraft strength. That's it. Because our sink rate's about like 200 feet a minute, right? So what this is, it tells you like where are you going to find climbs that are going up high enough that our paragliders can get to. and the scale, like the color scale changes as the day goes through. So, but I'm gonna scoot my thing over a little bit. There we go. So there on Wednesday, it's saying that basically the kind of the saddle side of the Ko'olau is where it's at. Around like noon. And then here's like, 1500. So the day's winding down. It's still saying, the yellow is not that great, less than 2500. The darkest color there is up to 4 grand. So they're saying that there's going to be like little pockets of climbs, not just, this is not cloud-based, but like climbs up to about like 4 grand maybe on somewhere on the saddle side of the Ko'olau. Okay.
So you're saying that height of critical updraft strength is basically top of lift?
Top of lift for us, not for the air,
Yeah.
right? Because the air
Yeah.
could be going more, but if it's not going up at
Yes, but for
200
us,
feet a
yes.
minute, yeah,
Yeah,
exactly.
yeah.
And I found that to be like, it correlates. It's not always like precise and accurate, but it definitely correlates. So if you know what it's doing today and what this says today, and it's a similar air mass tomorrow, you can correlate pretty good. And then the convergence one here is like our favorite. And we used, you could always see convergence just based on like winds, like what the winds at the surface are doing, and all the different layers, what the winds are doing. And but you'd have to build it in your head. But now the RASP just does it for us, where it shows like these hot spots of convergence, which is convenient. So here we have, and if we forget what we're looking at, I'll go back to the windy for the same day at the model and see. So we're on our surface winds here. So this is kind of a south day. So I would expect the convergence to be being pulled more up into the north of the island on a kind of a south medio day. Let's see.
Yeah, on the theory that if it was no wind, it would be equally like right in the center of the island.
Correct. So like, yeah. So on the perfect like zero medio day, the convergence sets up right at the heat center of the island, which is right around like, basically Wheeler into Mililani, like where this little X is going across the island. And so if we have a little bit of a north influence, then the convergence
pushes it down. Yeah.
The best convergence will be kind of where we can reach it from Nanakuli, right? Which is a little bit further south, like kind of just north of Pearl Harbor, because the Wheeler the Wheeler airspace will block where the best convergence band is most days, right? So unless it's like a Sunday and you're not worried about,
or Saturday,
or Saturday, yeah, monitoring the tower where you can fly around there and not have somebody upset about it. Then generally the north days are where the convergence will set up kind of just north of Pearl Harbor, where we can use it to connect, and get from Nanakuli over to the saddle side of the Ko'olau. Once you make it over to like Pacific Palisades and like Pearl Heights and stuff, it's usually working pretty good. So even if it's not convergence over there, once you made it over here, then it kind of works as you'd expect. It's like ridges and valleys, and the climbs are kind of where you think they're going to be, and it's not that hard. But getting across the flats is the hard part, and it's really nice to have those convergence bands. So let's see where it's saying. So yeah, so with the south flow as predicted, remember by windy. So here's noon. Here's 3 p.m. It's lighter, but still south. So we would expect that convergence band as the south wind kind of pushes and dominates a little more. It's still drawing in sea breeze on the North Shore, but where they meet is going to be a little north of where it normally is, and that's what we're looking here. So it's kind of like right across Mililani, like the top of Mililani there in Wahiwa.
That's a pretty classic central one, yeah. For Wednesday, I mean, it's like that belt in the middle is is pretty dead center.
Yeah,
it doesn't look like the south is pushing it very far north. I don't think it's that strong.
Right, and that correlates with what we're seeing here. Like this is like purple. This is like super light, right?
I always theorize that the best convergences look like a Hawaiian petroglyph. I don't know if you ever kind of turned on its side, like a dude with sometimes no head, but it's got like long arms and 2 little legs on the Hawaiian eyes.
Cool.
Once you see that, you can't unsee it.
I see it.
Yeah.
So this is all stuff you can do, everything I've been talking about up to like, the day of, and then on day of, like obviously like your observations are going to trump whatever your forecast says. So if your forecast said it's going to be awesome, then you walk out the door and you look up and it's just like already like a high layer, like an overcast layer, you already know that like the day is different than what you thought. And I would say like from the weather perspective, just having the confidence, like knowing the basics of this stuff gives you the confidence to go places because it's just one thing that you can tick off the list of things to worry about. So if you know that there's a stable layer, for instance, at like 5K, and that the clouds are not going to build above that, you know that if you're close to cloud and you can't see the top of it, you know that it's not that scary, right? So if it's just, it de-stresses you a little bit to have more knowledge. And I mean, anybody would agree with that, right? Like
Yes.
weather-wise.
More knowledge is less stress.
Yeah, you know, if there's no medio wind, if it's just a sea breeze, you know that, okay, let's say we want to fly in the saddle and it's like 11 o'clock and we're on launch at Nanakuli and it's getting stronger and stronger and we're like, ugh, like what's going on? If you know that it's a sea breeze day, you know that if you get to the back, it's going to be chill. So let's say it's too strong to launch at the main launch at Nanakuli. It's 11 o'clock. You know, maybe somebody's had like a couple inflations and it's just like super high end and they finally get like plucked off and you're like, shit. And by the time you set up, it's going to be like even more ripping. Then you can confidently say, you know what? I'm not gonna lay out here. I'm gonna go down to the low launch. I'm gonna get off of the low launch. I'm gonna get as high as I can. It's working awesome. It's gonna take me like 10 minutes to top out at the front peak, and I'm gonna go straight to the back, and it's gonna be chill. And you know it's gonna be chill because there's no medio wind. So when you get back there, it's like light wind. You're going trim every direction. You know the climbs are mellow because they're not like shredded by wind. Like at the front of Nanakuli, when the sea breeze is coming through, it's uncomfortable, right? Because you're like close to terrain and the wind is like shredding the thermals and they're hard to track and it's bumpy and it's just like not that awesome usually on the good days. But you know, like once you get to the back, light wind, all is good, and you get into the saddle and it's even better because you know you're super far from terrain. There's landings everywhere, and if you have a good idea of kind of what the day is going to do as you fly, then it gives you the confidence to go places you might not feel comfortable going if you didn't have a pretty solid handle on the weather. So yeah, that's kind of what I do. Stop this share here. Beep. So yeah, any like questions or further points that we want to talk about or clarify?
I don't think so. It's all super, super helpful. I feel like I'm just supplementing my weather tools. I'm stoked. Do you all use XC Skies ever?
I don't out here.
No.
That was kind of the boat I was in, right? Sorry, go ahead, Alex.
My impression was XC Skies when at least when it first came out, they didn't have any good information for Hawaii. Like they had something very basic, but it wasn't to the level of what we were looking for. Maybe it's improved since then, but I know people use it on the mainland for sure.
Yeah, I think I was using it kind of like as a relic when I first came out here. Literally, like the only things I use it for anymore are like just flipping through winds at altitude throughout the day, you know? And then like
Yeah.
in the past I've messed around with their SKU-T. They have the point cast, which is pretty cool, which I actually was kind of placing a lot of stock in when I first came out here. I was like, oh my God, the point cast can tell me what cloud base is going to be on any given day. But I found that what's a lot more accurate than that was just going outside and looking at the Ko'olau range, you know? But yeah, no, this has all been so helpful. Thank you guys for sharing the knowledge.
That actually reminds me of the other feature of the RASP that I don't know if anyone is using. I always look at it and scratch my head and think, is this accurate? What do they call that thing?
It's like the vertical column at the different flying sites, right?
Right. A windgram. They call it a windgram. So if you click on one of the sites, you see the windgram. And there's a ton of information packed into that thing, but I don't know how accurate it is for us. I feel like it struggles to wrap its little computer head around our island weather, that windgram. I don't know. Anyway, it's worth looking at, and maybe we could correlate it somewhat with our reality. But
well, it doesn't actually give you any information that you can't get just by looking at all the other parameters in RASP, right? Because it's just like a nice
different presentation. Yeah.
And like I had asked him when he was building it for us, like for a couple spots in the saddle, but all we got, he just made it for like our launches essentially. It was like, oh, it would have been nice to have one like right at Wheeler.
Right.
But, huh. All right. Yeah, so we're gonna wrap it. Anybody have anything else?
So Wednesday's a good day. I didn't look that far. Okay.
Yeah, Wednesday and Thursday, I think, were like the kind of the two best looking days.
Very nice.
Yeah, I think Wednesday. Oh, here we're gonna. Do a little screen share. Burp. Burp. So here's, yeah, so like Wednesday was looking, and both of these days had some like shower potential, right? But if you go to our plugin, there it is, and go back to our wind, go to like 1 p.m. So what do you think? Where would you want to launch on a day that's like kind of south? It's pretty light though, so you might be able to, let's see, early in the day. So it's kind of south.
Depends on your, yeah, depends on your mission, right? I'm actually
Totally.
tempted to do Cayena just to see what I can get out of there.
Right, so
That's
it's
a big
pretty
event,
light,
right?
and yeah, you can. I've definitely noticed you can launch like at the top of the ridge on the really light days, just on the anabatic flow coming up the ridge alone. If there's not really any medio out there, so that could totally work. Makaha might work. It's kind of blocked a little bit more back there. Hanakuli might be a little more exposed, but it's pretty light, you know. So if you could get away, then it's showing. Here's the back of the range is what they're saying is going to be happening. You know, so they're saying, yeah, it is stable, you know, at like 6,000, there's a layer of stability up to like 10,000. So that's kind of a thick cloud layer, but not super scary, and a relatively high base. Versus Thursday, it's kind of stronger north, right? So and if you're just looking at surface wind, you'd say like, oh, maybe Knob, maybe KMX. That could be like a launch from Knob and then try to like eke your way into the
What time is that? I can't see the bottom of your screen to see what time we're
this is
looking
12.
12 p.m.
Yeah, so here's like early morning, 9 a.m.
at. Oh, I see. Now I see. I had to hide all the little
That's
Zoom
like
faces
that's
to
like
see the time. Yeah.
2 p.m. and then like 5
Yeah,
p.m.
yeah,
So basically it's
yeah,
just
yeah.
filling in north throughout the day. So if
And what
you
model is that? Euro? Yeah, I see.
that's Euro. And so here let's throw our little sounding forecast, you know, kind of north of Wahua, which is like kind of where you'd be trying to get to if you were trying to get around Ka'ala into the convergence, which actually, you know, you're not going to probably be in convergence, because if it's north, the convergence is going to set up way down, like
down below.
north of Pearl Harbor.
Yep.
Right. So you're probably just going to be thermaling around in like slightly less sea breeze as you go towards the heat center of the island compared to on the coast. But it's not
Right.
going to be like that classic kind of day, and the base doesn't look that awesome even. Like $4,000. If this says $4,000, it's often like 3.5. So, you know, that doesn't look like an amazing saddle day to me. But
Mhm.
I'm curious what RASP says about it. Oh,
Yeah.
Thursday isn't up on the RASP yet. So
Right.
no.
Yeah, I don't trust anything more than what, 2 days out. 2 days out is like, even then it's changed dramatically sometimes.
Yeah.
Hey,
Totally.
Patrick, there's a comment or a question from Jason in the chat. Can I read it?
Oh yeah.
Yeah. There was a comment about looking at where different models agree or disagree. What are our opinions on precision and accuracy of higher versus lower resolution models?
If you're just talking about wind predictions, that's pretty easy to do. So like we can do that right now. So right now we're looking at the Euro model. Let's just look at Wednesday. So here's like 5 in the morning. So you just in your head, you're thinking, okay, it's like kind of light, sort of northeast, sort of east. Boop, as the day goes on, maybe it shifts. Okay, it shifts to like the south, but stays pretty light. And then by the end of the day, it's saying like it's actually like southwest. Okay, interesting. So let's switch models. You can go to like the GFS is not that great for like the island because it's such a big grid. It doesn't really take all the little terrain effects into account. But you can see if it's just like a general correlation or not. And so far, yeah, it's tracking more east, but it doesn't show that like south switch, which is to be expected with a bigger grid model, I think. And then you can look at the NAM.
You can also compare them all at once too, right? That's what I typically do. Like on my very, very first step, super high level, just click on like the little paragliding icon down at Machpu, look at all 5 models overlaid on each other and just be like, all right, what's the average here? And then from there, drill down into the WRF, etc.
Yeah.
I find it super helpful just looking at like all 4 of these models at the same time, just for the super big picture.
Yeah, but they're all kind of agreeing that it starts off like light, kind of north of east, and then clocks around a little more south. And so that to me says it's probably what's going to happen.
Yeah, I think it's turning quickly from post frontal to trades trying to set up, and then like no, another front's coming. You can't do that.
Yeah.
So my question kind of relates to I guess back to precision versus accuracy of the different models, right? So the NAM is a 3-kilometer model. You have a higher precision, but you generally higher precision, you have less accuracy.
I would
And
say,
the
yeah.
GFS
Yeah, for the NAM, it often will predict these wacky things that just aren't true. Like it'll often predict like these little cyclones and like little weird things setting up. And like, what is that? And like it often, you could totally interpret like a level of precision that's just not there with that model if you only looked at the NAM. Versus the WRF, it's usually it's even a smaller grid size, right? It's 1 kilometer versus 3 kilometer, but for whatever reason, how it's fed the data, it's more pertinent to what's actually happening on our island.
Agreed.
And so it
Yeah,
actually,
agreed.
like you look at it and it'll show like, you look out at Cayena Point and it'll show like, here's a little south coming in on this side and a little north on that side. You're like, oh, interesting. And then you go out there and sure enough, that's what's happening a lot of the times. So I think it does depend on the model and how it's built and where they're getting their data from. It's not just the grid size.
Yeah, interesting. Thanks.
All right, should we call this thing?
Yes.
Yeah.
Thank you, Patrick.
Sweet. Yeah, it was fun. We'll put the recording up on my super popular YouTube channel.
Thank you, Patrick. I got this loud jazz music and stuff going on over here, so I wasn't able to like put anything on mute.
Yeah, no problem. All right.
Thank
Cool.
you, everyone.
That was awesome. Thanks, guys.
Yeah, thanks everyone for your input.